So in this video what we want to do is to calculate the following indefinite integral where the integrand is 1 over 1 plus the square root of x, and it's this square root of x factor which means that the integral is not easy. If it was 1 over 1 plus x it would be a straightforward integral, it would just be a logarithm. So it's natural to say let's try a change of variable, let's try a simple substitution. Let's say that u is the square root of x. In other words, u is x to the half, and that means that du dx is the derivative of x to the half. You pull a half down in front, reduce the power by 1, so you have x to the minus a half, and that is 1 over the square root of x. Now, let's also recall the key formula that follows from the chain rule, that if you have an integral of some function of a function written in terms of a variable x, and it's multiplied by du dx, and then it's integrated with respect to x, this can be calculated by just integrating our function of u integrated with respect to u, and at the end we replace in the integral u by u of x. So this is our key formula, and this is our attempt at a substitution, because this is going to give us 1 over 1 plus u, and that is an easy integral. Now the problem here is immediate. It is that the du dx factor 1/2 1 over the square root of x is not here in front. So what we're going to do is we're going to attempt to insert a factor of 1 here, so that we're not changing anything, we're just multiplying our integrand by 1, but in a way that is helpful. So if we call this integral I, what we're going to do is say that I, our integral, is the integral of 1 over 1 plus the square root of x, that's the original integrand, multiplied by 1, which we can always do, and our 1 is going to be 2 times the square root of x times 1 over 2 times the square root of x integrated with respect to x. So all we've done is we've taken this and rewritten it in this way with this factor of 1. And we've chosen this particular way of writing 1 because this factor is du dx. And this can be rewritten in terms of u, which is very helpful because u is just the square root of x. So this is du dx, this factor here, integrated with respect to x. So we're going to replace all of this by integral with respect to u, and everything here, including this new factor, becomes this, so we're just going to rewrite it in terms of u. So I, our integral, is the integral of 1 over 1 plus u times 2u, that's this factor here, integrated now with respect to u. So let's just rewrite this. We'll take the factor of 2 outside, so this 2 will just take it outside, but the u of course is part of our integrand, we're integrating with respect to u. So we've got 1 plus u on the bottom, we've got a u on the top, and what we do now is, a moment ago we multiplied by a factor of 1. What we're now going to do is to add nothing to the top. And again, we're going to add nothing by adding and subtracting the same thing. So here I'm going to add 1. So I'm just going to add a 1 to this u, and I'm also going to subtract it. And as you can see, this means that we've not changed the numerator at all, but by doing this we are going to be able to calculate the integral. So here's the measure again. So what we've done here is we've realized that here we have a rational function. We have a polynomial, a very simple power of u, divided by a polynomial on the bottom, that's a rational function, and the power in the numerator is at least as high as the highest power in the bottom, so therefore this is an improper rational function, and what we're trying to do is just to rewrite it in a way where we have a proper rational function, so plus a polynomial. So by adding and subtracting these ones, we have a 1 plus u in the top, which is the key that we're looking for, because 1 plus u and 1 plus u will cancel. So we see that our integral I is 2, that's the factor outside, times the integral of 1, that's 1 plus u divided by 1 plus u here, minus 1 over 1 plus u, all integrated with respect to u. And this is 2 times, let's open a bracket, 2 multiplies everything, the integral of 1 is u, minus, and now the integral of 1 over 1 plus u is the natural logarithm of the modulus of 1 plus u. Close the modulus, close the brackets, and this is an indefinite integral, so there is an unknown integration constant. And what we do now is just we rewrite this in terms of our old variable, our initial variable x, because we've been able to do the integral. So therefore what we see is that the integral 1 over 1 plus the square root of x integrated with respect to x is equal to 2 times, and u was the square root of x, so it's 2 times the square root of x minus the logarithm of the modulus of 1 plus the square root of x, close modulus, close brackets, plus an unknown integration constant. So this is our result for the integral, and it's a good exercise to check this by differentiating it and seeing that if you differentiate our result, you get back to the initial integrand. It's also worth trying to do this integral in a different way. So what I would also recommend is that you try to do this integral with the substitution that u is 1 plus the square root of x, and that also works. So there are different ways you can do things, and what we've seen in this particular case with this particular change of variables is for this integral, this square root was the problem, and using our key formula here and inserting a factor of 1, we were able to integrate with respect to u, and our integrand, our new integrand, could be written in terms of u, and this was an improper rational function, and by adding and subtracting 1 in the numerator we get down to a polynomial, just a 1 in this case, and a proper rational function which we were able to integrate quite straightforwardly. So I hope that's been useful to you, and I think it's worth trying the integral again with this, and obviously you should get the same result. With that, I'm going to stop the exercise.